The Cretaceous period lasted 80 million years and ended 66 million years ago. Marine paleontologists spent decades studying apex predators like mosasaurs and plesiosaurs. Then fossil discoveries from 2018 to 2023 revealed something terrifying. The deadliest creatures in Cretaceous oceans weren't the giants everyone studied. They were mid-sized pack hunters that killed with coordinated precision nothing alive today can match. Modern oceans have great white sharks hunting solo, orcas hunting in pods of 5 to 10, and that's considered sophisticated. Not to worry though, Cretaceous oceans had prognathodon groups numbering 30 individuals coordinating attacks on prey 10 times their size. Bite mark patterns on mosasaur fossils prove smaller predators didn't avoid the giants. They hunted them systematically. You couldn't escape to deeper water because that's where the packs waited. The Western Interior Seaway covered central North America during the late Cretaceous, stretching from the Arctic Ocean to the Gulf of Mexico. This inland sea reached depths of 900 meters, or 2,950 feet, deeper than 3 Eiffel Towers stacked vertically. Scientists assumed apex predators like Tylosaurus dominated through size and power, similar to modern apex sharks. A 2018 discovery in Kansas changed everything. Paleontologists found a complete Tylosaurus skeleton measuring 12 meters or 40 feet long as a city bus. The skeleton showed extensive damage, but not from another giant predator. The bones had dozens of bite marks from multiple smaller mosasaurs, each bite measuring 8 to 12 centimeters or 3 to 5 inches wide. The bite patterns revealed coordinated targeting. Smaller predators attacked the flippers first, shredding muscle and tendons to prevent escape. Then they targeted the tail, destroying the propulsion system. Finally, they attacked the body from multiple angles simultaneously. This wasn't scavenging. This was systematic pack hunting that disabled prey through strategic strikes. Shockingly, the hunters were prognathodon, a mid-sized mosasaur measuring just 6 meters or 20 feet long, half the size of their victim. Computer modeling of the bite marks proved at least 15 to 20 individuals participated in the kill. Modern orcapods rarely exceed 10 members. Cretaceous ocean predators coordinated groups 3 times larger. But here's what makes it worse. A 2019 study from Sweden examined prognathodon tooth structure using CT scans. The teeth weren't designed for cutting like shark teeth or crushing like crocodile teeth. They were designed for gripping and tearing, identical to modern piranhas. Each tooth curved backward with serrated edges, measuring 5 centimeters or 2 inches long. Prognathodon jaws contained approximately 40 teeth arranged in multiple rows. When one tooth broke during attack, replacement teeth moved forward within days. You couldn't disable these predators by damaging their weapons because the weapons regenerated continuously. Modern sharks have the same adaptation, but prognathodon teeth replaced faster and gripped tighter. In case you needed more proof, researchers analyzed swimming mechanics. Prognathodon had shorter, more muscular bodies than larger mosasaurs. This anatomy sacrificed top speed for acceleration and maneuverability. The tail flukes were proportionally larger, generating explosive bursts reaching 45 kilometers or 28 miles per hour in under 2 seconds. Faster acceleration than modern dolphins. Unfortunately for Cretaceous marine life, speed bursts enabled hit-and-run tactics. Pack members took turns attacking, each individual striking at high speed, then retreating before prey could retaliate. The victim bled from dozens of wounds simultaneously, while pack members remained largely safe from counterattack. The hunting strategy worked because Cretaceous oceans had visibility conditions modern oceans lack. Volcanic activity pumped massive amounts of nutrients into the water, triggering plankton blooms that reduced visibility to 3 to 5 meters or 10 to 16 feet. You couldn't see pack members approaching from multiple directions until they entered strike range. No modern ocean does this, but Cretaceous seas had thermoclines, temperature boundaries, at multiple depths. Prognathodon could dive beneath warm surface layers into cold, deep water, then attack upward from below. Thermal layers masked their approach because prey species concentrated in warm water couldn't detect temperature changes from predators in cold water. A 2020 study from Japan examined prognathodon brain cases. CT scans revealed enlarged olfactory bulbs, the brain regions processing smell. The olfactory bulbs were proportionally larger than those in great white sharks, which can detect 1 drop of blood in 100 liters of water. Prognathodon likely detected blood at even greater concentrations. This capability transformed pack hunting effectiveness. One pack member wounded prey, releasing blood into the water. Other pack members detected the blood from distances exceeding 500 meters or 1,640 feet, over 5 football fields away. The entire pack converged on wounded prey within minutes, regardless of visibility conditions. Talk about nightmare fuel. Coordinated pack tactics, explosive acceleration, regenerating teeth, and sensory systems that tracked prey through blood detection across distances modern predators can't match. Then researchers discovered Prognathodon wasn't the only pack hunter. Platecarpus, a smaller mosasaur measuring 4 meters or 13 feet long, showed identical social hunting behavior. Fossil beds in Alabama contained multiple Platecarpus skeletons alongside partially consumed plesiosaur remains. The bite mark patterns matched Prognathodon kills, systematic targeting of flippers, tail, then body. But Platecarpus added a terrifying innovation. The jaw structure allowed the mouth to open 110 degrees, wider than pythons. This extreme gape enabled Platecarpus to bite chunks weighing 10 kilograms or 22 pounds from victims in single strikes. Modern piranhas strip prey through thousands of small bites. Platecarpus stripped prey through dozens of massive bites. The 2021 study from Germany examined fossilized gut contents from multiple Platecarpus specimens. The stomachs contained remains from at least 6 different prey species, including fish, smaller mosasaurs, sea turtles, and ammonites. This dietary diversity proved Platecarpus packs didn't specialize on single prey types. They attacked anything that entered their territory. You couldn't even hide in the shallows. Platecarpus fossils appear in deposits representing water depths from 10 meters to 600 meters or 33 feet to nearly 2,000 feet. These predators hunted across the entire depth range, from surface waters to deep ocean. No safe zones existed. Shockingly, juvenile mosasaurs showed the same pack hunting behavior as adults. A 2022 discovery in Morocco found a fossil assemblage with juvenile Prognathodon measuring just 2 meters or 6.5 feet long alongside partially consumed fish remains. The bite marks proved juveniles hunted cooperatively before reaching adult size. Pack hunting was learned behavior, not instinctual aggression. In case you needed more proof, tooth isotope analysis revealed these packs remained stable over time. Chemical signatures in teeth lay down annually like tree rings. Multiple individuals from the same fossil site showed matching isotope patterns, proving they fed in the same locations over multiple years. These weren't temporary hunting groups. These were permanent social structures more complex than modern shark behavior. The fossil record reveals escalating marine predator diversity throughout the Cretaceous. During the Cenomanian stage around 95 million years ago, the Western Interior Seaway contained at least 8 mosasaur species, 4 plesiosaur species, and dozens of shark species. All of them competed for the same prey base. This competition drove innovation in hunting strategies. A 2023 study from Canada examined bite force across different mosasaur species. Prognathodon generated 6,000 newtons of bite force, comparable to modern saltwater crocodiles despite being smaller. But smaller species like Platecarpus generated just 3,000 newtons. The difference in bite force correlated with pack size. Weaker biters formed larger packs to compensate. Unfortunately for prey species, this meant more predators per attack. Victims faced either small groups of powerful biters or large groups of weaker biters. Either scenario resulted in rapid death through overwhelming coordinated damage. Modern oceans don't have this problem because apex predators hunt solo or in small groups. The prey species reveal the scale of Cretaceous ocean danger. Xiphactinus, a predatory fish measuring 6 meters or 20 feet long, had jaws powerful enough to swallow human-sized prey whole. It was apex predator in modern terms. In Cretaceous terms, it was prey. Multiple Xiphactinus fossils show mosasaur bite marks, proving even apex fish got hunted by marine reptile packs. Archelon, the largest sea turtle ever, measured 4.5 meters or 15 feet long, with a shell 30 centimeters or 12 inches thick. Modern sea turtle shells protect against most predators. Cretaceous mosasaurs crushed Archelon shells like potato chips. Fossil evidence shows bite marks penetrating completely through shells into internal organs. Then there were ammonites, shelled cephalopods reaching 2 meters or 6.5 feet in diameter. The shells were armored spiral structures that should have provided defense. Mosasaur jaws evolved specifically to counter this defense. The rear teeth acted as shell crushers while front teeth gripped soft tissue. You couldn't hide inside armor because the armor got destroyed. No modern predator demonstrates this level of specialization against armored prey. Sharks avoid heavily armored prey. Orcas target soft-bodied prey. Cretaceous pack hunters attacked everything regardless of defensive adaptations, using coordinated tactics and specialized anatomy to overwhelm any defense. A 2023 study from France used artificial intelligence to model Cretaceous ocean food webs. The AI analyzed thousands of fossils, mapping predator-prey relationships across 20 million years. The results showed mosasaur pack hunters occupied a unique ecological position. They functioned as both mid-level and apex predators simultaneously. Small packs hunted mid-sized prey through speed and coordination. Large packs hunted apex predators through overwhelming numbers. This flexibility prevented any single species from dominating the ecosystem. Modern oceans have clear apex predators. Cretaceous oceans had fluid hierarchies where pack size determined dominance. The Western Interior Seaway eventually drained as sea levels dropped, but while it existed, it contained predator diversity and sophistication unmatched in modern oceans. Over 30 different mosasaur species evolved, each with specialized hunting strategies. Some hunted solo using size and power, others hunted in pairs using coordination. The deadliest hunted in packs using systematic tactics refined over millions of years. The fossil evidence proves Cretaceous oceans were deadlier than modern oceans in every measurable category. More predator species, larger pack sizes, better sensory systems, more sophisticated tactics. Victims faced coordinated attacks from multiple angles with no escape routes and no safe depths. That's the reality of Cretaceous marine ecosystems. Not peaceful seas where giant predators lazily picked off slow prey, but violent hunting grounds where mid-sized pack predators used intelligence, coordination, and specialized anatomy to dominate. Scientists thought they understood Cretaceous ocean food webs. The fossil evidence proved those webs were far more complex and far deadlier than anyone imagined, and nothing alive today hunts with the sophistication these ancient packs demonstrated.